Hi everyone. So this is my second video on the standard normal distribution. And in the previous video, we covered that any normal distribution can be transformed to this standard normal distribution where the mean is 0 and the standard deviation is 1 using this formula. In this video, we're going to look at calculating probabilities using this model. So we've been asked to use the calculator to find the probabilities to three significant figures. So for part A, the probability of a random variable z being less than or equal to 1.92. If we show this as an area on our diagram, we've got the z value of 1.92, which I'll label here. What we're trying to find out is the area of this shaded region. So if we go to our calculators, we'll press menu, we want option 7 for distribution, we want option 2 for normal CD. Now the lower we can see is at -3. In actual fact, I could put in any value less than -3. The upper is the value of 1.92. We know the standard deviation is 1, and we know the mean is 0. So we get the probability is 0.971 to three significant figures. Okay? Part B. Now we want the probability of z being less than 0.97, which is around this region. So we'll mark this off as 0.97. The area of this region is the probability we're trying to find. So we'll go back to our calculators. We'll go back to the normal CD. We'll keep the same lower of -3, but now we want the upper as 0.97. We'll keep the same standard deviation and mean. We'll press equals, and we get 0.833. Again, to three significant figures. Okay, so for part C, this should be a z, not an x. So a probability that z is less than -0.34, but greater than -1.12. So we'll show this in our diagram. We can enter this into our calculator. We want the lower of -1.12. The upper is -0.34, and we'll keep the same sigma and mu, and we get 0.236. Moving on to part D. Find the probability that z is less than -1.2, or that z is between 0.3 and 2.1. So it's much easier to understand what's happening here if we shade it in the diagram. So we've got less than -1.2, and then it must be less than 2.1, but greater than 0.3. So if we begin by working out this probability, we'll say the lower is -3, the upper is -1.2, and we get a probability of 0.114. Working out the second region, the lower is 0.3, the upper is 2.1, and this gives us 0.364. But we're told in the question it can be one or the other, and this means we need to add the two probabilities. So if we go back to our calculator mode, we'll have 0.114 plus the 0.364, and we get 0.478. Okay? So now we're going to look at how to use a table with a standard normal distribution. So one of the benefits of a standard normal distribution is that we can use this percentage points table to quickly find a z value from a fixed probability. So in part A, we're told that the probability of our random variable z being greater than the observed value little z is 0.15, and we're trying to find this observed value. So if we shade this on our diagram, what we want is an area of 0.15. And because it is greater than z, this will be to the right of the average. So if we look at our table to find the probability of 0.15, we can see that the z value must be 1.364. So we can mark this on our diagram as 1.0364. Okay, and that would be the z value that we've been asked to find. Part B, probability that z is greater than the observed value is now 0.2. So again, this will be to the right of the average. So we'll look at our tables. The probability is 0.2, and this gives us a z value of 0.8416. So I'll mark this on our diagram. And then finally, for part C, the probability that z is less than the observed value equals 0.6. But you can see from our table that the probabilities only go up to 0.5. But because this is less than z, we know we're starting from this point, and this must have an area of 0.6. So if I make a mark about here, if this has an area of 0.6, then we know that the purple region must be 0.4. And we can work out the z value using this probability. So we know the probability of 0.4 is 0.2533, which we can mark on our diagram. And this is a nice example of where we can use the symmetrical properties of the standard normal distribution. So thanks very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.